two speakers for our first presentation. We have Richard Raustad from Florida Solar Energy Center at UCF, and we have Dr. Cesar Srinivasan, assistant professors from Tuskegee University. Okay, so I'll get started.
Hello everyone, I'm Richard Raustad with the Florida Solar Energy Center. We had a cancellation on our presentation, so we decided to give you a little bit more information about the Electric Vehicle Transportation Center. We just got started last October, have defined just over 20 projects that cover the scope of our center. And I'm going to give you a little bit of an overview here. That our university partners, I've already told you this morning that UCF and Florida Solar Energy Center and Tuskegee University and the University of Hawaii. A little bit of a view of our organizational chart. UCF leads. The Florida Solar Energy Center is where we're directing the EVTC from. That's where Dr. Block resides. So we have our transportation center, and then we have an oversight committee, a steering committee, and we have performance metrics to measure our progress over the course of the next 4 years. You see FSEC, UCF Electrical Engineering, UCF Civil Engineering, University of Hawaii and Tuskegee in purple down there, and then our programs and projects are down at the bottom in red. A little bit of R&D, we have some industry collaboration, education and workforce development, and of course information dissemination. Our research is categorized into policies regarding electric vehicles. We have HOV lane access, we have charging station siting issues, government regulations. The next category you see is data gathering. We hope to do some real projects of connecting batteries to buildings or plugging in electric vehicles to buildings and seeing what that interaction is like. Maybe some utility demand or building peak shaving. If the vehicle is plugged into the building all day long, not being used, can we use some of the energy in that battery to help augment facilities operations? There's timing issues and charging. There's putting photovoltaics along with the batteries and car chargers. There's a lot of interactions that we'll have in the future regarding electric vehicles. EV site data and analysis. We're going to do grid experiments and look at V2G and with respect to commercial buildings, how the vehicle can interact with the building on a daily basis. Of course, I've already mentioned standards. Standards regarding the type of plug for the charging station, subsystems of electric vehicles, fuel cell and battery technology. We have several parties looking at those different aspects. And then our specialized EV applications. We've got fleet vehicle sets. We have a big group at the center that works with clean cities. They do a lot of work with fleet vehicles and how those fleet vehicles can use alternative fuels. We're going to look at fleet vehicles with respect to electrified transportation. Florida Turnpike is really involved with us to try to get us to tell them, when do we need to put charging stations on our turnpike? They have not yet done so. They're waiting for this research to help them plan for the future. And then large-scale social impacts and technical impacts. How will EVs impact society as a whole? And what are some of the technical challenges we face? These are just a few of the EV charging scenarios we see for the future. On your right is a drop-in place EV charging station. I imagine this would require no permits whatsoever. You have a quick need, let's say, to allow EV charging at your facility. This is mobile. You can just just put it on the truck and move it to a different location if you wish. And then on the left is more of a stationary application where PV is assisting to charge the vehicles. I think in the future we're going to have a lot of issues with demand charges for these charging stations. If you're going to charge your vehicle quickly, you're probably looking at somewhere between 20 and maybe even 100 kilowatt of power required to charge your vehicle quickly between 5 and 15 minutes. The faster is better, of course, and that means a higher demand charge. Commercial buildings are typically charged about $10 per peak kW each month. So if you turn on a charging station and you hit 100 kilowatts, that's going to cost you $1,000 a month on your utility bill. So how do we address that charge? And that will also ruin the economics of electric vehicles. Building owners will not want to pay that extra $1,000 a month just to allow their employees to plug in. And you can imagine if there's tens or even hundreds of vehicles plugged into your building, what that could do for your electric bill. So we're going to look at PV assistance, battery storage. These vehicles in 10 years will need to have their battery replaced. There's going to be literally hundreds of thousands of storage batteries available for some secondary use application. We're going to look at what those applications might be and how these batteries may be able to interact with the building and possibly reduce demand charges on a utility bill. Here, top center picture is a real good image of what we think V2G will look like in our project. That's a Nissan Leaf plugged into a Nissan V2G charging station. So that station performs the charging function for the vehicle, but that station also can backfeed from the vehicle battery into the household. Over in Japan, they have about a 24 kilowatt hour on average daily energy use, and the Nissan Leaf's battery is about 20 kilowatt hours. So almost a day's worth of energy is sitting in their garage. If they have a power outage, they can pull off the battery and, on an emergency basis, and feed some of their home appliances or what have you. Of course, the vehicle will then need to be charged if it's going to be moved, so there's economic and technical issues associated with doing something like this. Bottom left is a battery. That's the Nissan Leaf battery. Top right is the Chevy Volt battery configuration. Up in the upper left, you see a Chevrolet battery storage facility. Utility companies are now starting to connect these battery storage systems to their utility grid to help improve the quality of the utility service. Charging stations put a lot of harmonics on the grid. If you understand how those harmonics impact the grid, you may be able to do something about it with either some other electrical hardware, or in this case they have battery storage to modulate or regulate the voltage on the grid by either drawing from the grid to the battery or from the battery to the grid to maintain a constant voltage. In the lower right, you see the Tesla supercharger station. Those are going up across the country. That's free to Tesla owners, but that's also, there's a price to pay for that if any of you know how much a Tesla costs. Now this graph I found from our Hawaii partner, and I think this sums up quite a bit of what we'll see over the next 4 years, at least on our project. The top blue line is the utility load profile. This is from the utility company's perspective. And on the bottom, you see the orange line in the center. So and Hawaii's unique in that it's an island surrounded by water. They generate all their electricity on their island. They can't import electricity. They import the oil to run their generators to create their electricity. So on this island, as renewables increase, you'll start to see that orange line become higher and higher and higher. And what that does is that offsets the actual utility load. And that would be the light blue line you see in the middle that's dipping below the dotted line. And the dotted line is the minimum output of their generators. When their actual net load dips below that line, they have to start curtailing their renewable energy production, which means they're actually wasting it. So how can we use more of the energy as opposed to curtailing it or losing it? We can now start plugging in electric vehicles, we can use battery storage devices, and we can save that curtailed energy for later use. I think that is a very nice slide that sums a lot of things up on our project. We have some existing programs at the University of Central Florida that we will be partnering with, if you will, that have already worked in education and training. That would be the feeder program. That's an electric utility program funded by DOE. The Clean Cities Coalition, there's several of those throughout the United States. They deal with alternative fuels and fleet vehicles. Okay, if we had battery backup and storage on this computer, now it's a perfect feed. I can see it on my monitor. Oh, on the other slide? Okay, so feeder program Clean Cities, our Southeast Solar Training Network, that trains people in the installation of photovoltaics. You see we have a training network already in place. We just add the information of training people on electric vehicles and their operation, about information about the batteries. And we also have a Building America program which targets the buildings themselves and how to be more energy efficient. It's a perfect synergy there to now include an electric vehicle with a building and see what type of additional energy improvements we can get based on having just that vehicle or battery connected to your commercial or residential building. This is kind of an overlook of the feeder program. There's 7 different universities involved. We have utility, of course utilities the ones interested in this because we're looking at the utility grid itself and we're training our future engineers needed to run those types of programs. NREL and Los Alamos are involved, and there's many manufacturers that are also interested in, of course, the electronics manufacturers, because that will be the type of equipment we need to improve the quality of our grid. At Clean City Central Florida, the lady that directs this program is part of our Electric Vehicle Transportation Center, so it's a perfect marriage there. They deal in alternative fueled vehicles, mass transportation, which we're looking at, and fleet operations. The Building American program itself has now for the last 7-8 years been dealing with commercial buildings and their improvement and efficiency. We think it's a perfect marriage for it now to be looking at how electric vehicles will impact either residences or commercial facilities. And then workforce development. We're going to cooperate with our existing agencies and use those existing contacts to further develop and improve the deployment for electric vehicles for the future. Our Southeast Solar Training Network, this is the network that trains individuals to install photovoltaic systems throughout the Southeast. It should be an easy addition to train them in another specific field. At least we have the contacts and the network, whether it's within this organization or a parallel organization is TBD. And then we have education and outreach. I think I'm going to let Dr. Srinivasan take it over from here, since the Tuskegee University will be handling a lot of our STEM and education.
Thank you. So, Tuskegee University is top rank, historically black colleges and universities, minority serving institution in the state of Alabama. We work probably close to 4,000 students, primarily focused on undergraduate research and education. We are partnered with this EVTC program to look for the minority STEM education, where we can take an advantage of the electrical vehicle program into the course curriculum and also education and outreach. Okay, one of the course curriculum currently we are working on, since we got funded from last October, as Rachel said. So we are currently looking on the course curriculum, how can seamlessly incorporate the EVTC into our one of the senior level courses, modern physics labs. Currently we have our primary dialogue with the Alabama Power, and the students are currently taking the senior level laboratory course, where they were supposed to go to the Alabama Power site. They have a big electric vehicle program, So the students will learn the different electrical vehicles operations, components, charging stations and current status. Then they have to come up with a report. There are currently 6 students involved, and then we are there planning for the spring 2014 to take this project. The second one is we also seamlessly incorporate the STEM education into the undergraduate research and training. Currently, the outcome of the EVTC program, the 6 to 8 students, they submitted a local proposal that's called the prototype proposal to the Sigma Pi Sigma Physics Honor Society, and they got awarded $2,000 primarily for undergraduate research students. This is the check we received basically for primarily the students who wrote by themselves, and then okay, so the students, they got there, so the check is based on their research and their contribution. Also students involved in working on the outreach activity. Recently the department, the students got the Marsh M. White Award, which is an outstanding outreach activity which we are currently implementing at the Tuskegee community. So the next slide, which is not seen here, but I could see from here on the monitor, there's a big education outreach program we are planning for 2016. That means it's down the road, but still it's a big congress which is coming up in the Bay Area, 2016 Quadrennial Physics Congress, which is widely attended by the undergraduates, graduates, about 5,000 students. And as a planning committee member, I have proposed this. There's a satellite symposium on EVTC, Electrical Vehicle Transportation Center, which is primarily open to this community, where we will invite the expertise people and also the satellite sessions on the alternative electric vehicles, which is in 2016 in California. The next one, which is, it's very unfortunate not to show here, but I see that we have done it's kind of an annual event. We are just keeping up. The Tuskegee is most underdeveloped city, where we try to put our effort as a university partner to develop the K-12 outreach activities. The students are trained on this EVTC program, will go to the community, either the elementary school and the high school. They take back into the outreach activity with the students, and then they create awareness, not only for the students, but also to the teachers. Because most of the teachers, as a science teachers, you won't see their background is not in science major. They may be having some political or, so this is an activity which we have currently in place, and we are trying to implement this in the future as the program is building up with the EVTC. One other thing is to keep the students in STEM education. That's very hard, because sometimes the freshman who comes to the freshman stage, they may have so many distractions, they may have so many options. We wanted to keep them in track, so we more focus onto the fast track summer program, where we involve the students as a freshman. Our undergraduate senior students will demonstrate. This has been done in the last semester. So the students will peer tutor and peer encourage the students to keep their options in STEM program. That makes that for the 4 years, they may come up with the flying colors of getting job opportunities. So then, as I said, that we have also a program with the K-12 teachers. Like STEM teachers, they just stop by at the Tuskegee University and then work with the professors there to enrich their knowledge. So these options are now, we are creating a platform with the help of the EVTC program, which is in place. Also, we conduct the joint annual research symposium with the students. Thank you for this. And if you need more information, you talk to or you can contact our center director, Dr. Block. Thank you.
That has nothing to do with privacy issue. Speaker is Dr. Seckin from Florida International University.
Hello? Okay, it's working. Good morning, everyone. My name is Seckin from Florida International University. This is a project sponsored by Blocking. Project sponsored by National Center for Transportation System Productivity and Management. I want to acknowledge my co-authors, Zhang, master student, who is helping me on this project, and Dr. Albert Gan, who is also, we spent, as you will know, one of the major tasks for this project is developing a nationwide survey on TMC operations. And it's a very challenging task to figure out how to ask the right question and the right way to ask the right questions. So Dr. Gan and me, there are lots of discussions and back and forth on the actual survey question, and so I want to acknowledge my co-authors. The topics: traffic management centers, challenges, best practice, and the future plans. First, I'll go over the background. What's the purpose for this project, the objectives that we're hoping to achieve through this project, and then the focus areas for this research. And finally, the survey design is still an ongoing research, so we don't have much results to present, but hopefully this information could be useful for you. I'll just the background. As we know, traffic management centers, they serve as the technical and the institutional hub for information collection, data integration, and information dissemination, help us monitor and manage the transportation system. So it's directly related to the efficiency and success of our transportation system. So the goal of this research is to provide an updated and a comprehensive scan of current practices in TMC operations. And we are trying to focus on latest technologies and tools that may help shape the future of our traffic management centers. The objectives, there are two objectives. First, update the knowledge in TMC practices in terms of the latest technology and tools and strategies in addressing new challenges focused by urban traffic management agencies, faced by urban traffic management agencies, and establish a general standard in TMC performance, hopefully provide some directions for future plans. We've done a lot of comprehensive literature review, mostly focused on federal guidelines and reports on the focus areas or functional areas by traffic management centers. And we decided to focus on these areas to develop our survey. 5 areas. First one is current tools or applications used in TMC operations, focusing on 5 functional areas: traffic management, incident management, traveler information dissemination, construction and maintenance activities, and performance monitoring and evaluation. The second major area will be traffic incident management performance measures. This too is to help us establish a standard or set the stage on where we are now in terms of tools, applications, and performances in TMC practices. And the next 3 focus areas, this is more looking into the adoption or integration with new technologies and tools and help us to look into the future. One area is practices in data and information sharing, such as integration, third-party data, or adopt some of the integrated corridor management initiatives in terms of integrating freeway and arterial operations, sharing data between highway and transit agencies for coordinated management and control. In this part, we also look into some of the areas for integrating connected vehicle data to help the TMCs better monitor or gather information, and at the same time, maybe, so this will be a 2-way street, and the TMC can also provide information to the vehicles. The second area will be potential enhancement with new technologies. This could include automation tools like automated graphical user interfaces to help the operators improve efficiency, and using advanced wireless technologies in the agencies, and also taking advantage of social media tools for traveler information and crowdsourcing. The last focus area for this survey will be on staffing and skill needs. As when you think about it, to integrate new technologies or new tools, probably you will also need additional or new set of skills or staffing resource to help improve these practices. So these are the 5 focus areas that we have incorporated in the survey. The survey design, sample frame, we are targeting at TMCs across the country. Hopefully we can have a nice coverage geographically and institutionally. Sample size, we've distributed the survey to about 80 TMCs. We're hoping to get 30 to 40 responses. I think that will help us to get enough information to analyze the data. Recruitment, we sent out email invitation to TMC contacts, and hopefully it's indicated that the survey needs to be filled out by a TMC manager or someone who's familiar with TMC activities. And it's a web-based survey, so there's a link in the email invitation. They can just go online and fill out the survey questions, and the answers will be automatically transferred into a spreadsheet. This survey is sponsored, not sponsored. This survey is built upon a Google Forms platform. It's a very user-friendly instrument to use to develop surveys. You can change the questions quite easily, and it's simultaneously reflected on your survey questionnaire. Here I want to acknowledge help from Dr. Alex Stevanokic from Florida Atlantic University. He provided the list of TMC contacts for us for this project. So I distributed the survey links to TMC contacts. In terms of the questionnaire, we have included both fact-finding and opinion-seeking questions from TMC managers. There are about 32 questions in the survey. We estimated it will take about 30 minutes to finish. So it is a little bit, it takes a bit time for the respondents to fill out. So we're expecting, we're sending out reminder emails, hopefully to increase the response rate. The survey invitation was sent out last Tuesday, March 18th, and we are closing it next Friday, April 4th. So far, I've been monitoring the response on my cell phone. So far, we've received 9 responses. We got 2 responses the first day, 1 the second day, and 6 responses last Friday. So today is Monday. Hopefully, we have more coming in. And then maybe next time we have more results to present. This is the survey link. Let me try to see if we can actually see. Oh, the other problem we have encountered, because this is built on Google Forms or Google Docs platform, some DOTs, they have different level of network security. So the link was blocked. Was blocked. So it can, some DOT agencies, they cannot access this web page. So hopefully they can build it on their home. Some of them have already done that. You can use a computer outside of your agency network. And it should fill out the form. For the others, we also prepared a paper or electronic survey, if they prefer, we're going to send them the survey. They can fill it out and then just email it back to us if they have difficulty access the web page. This first page is just an introduction of the survey, the purpose and focus areas. And then this one, first page asks some general information about the agency, name, position, title, geographic area covered by the agency, whether they are statewide or covering urban region or both urban and rural area, whether they belong to a DOT, district office, or local county or city government, and some general information about their services. Because this is the real survey form that the respondent will see, there are some questions that they have to, you have to fill out the information to be able to move on to the next page. So, and I don't think I have time to actually show you the next page. So, but I have copied some questions on my own point, if we can get back here, just to get a sense on different forms of question. I have both multiple choices and check boxes and some of the opinion ranking questions. So this one is a checkbox question asking types of real-time data that TMC currently obtains from external entities, such as agents, can be public agencies or third-party data, just to get a sense whether they are receiving data from external entities right now, and we can get a sense in the future. And this is an open-ended question, so they could fill in whatever methods or system they are using currently for data archiving and management. This is another example for opinion-seeking questions, asking them to rank these strategies in applying social media tools for their TMC operations, from least helpful to most helpful, or if they are not sure about this, they have this option as well. This is another type of opinion-seeking question. So instead of ranking the importance or effectiveness of a certain tool or facility, they can agree or disagree with the statements. In this case, we are asking whether contract or privatized operations and maintenance are likely to be increasingly adopted by TMC as it relieves the needs to acquire and maintain staff with the required skills. So these are the different types of, the combination of different types of questions that we've included in the survey questionnaire. And that's my last slide. So I guess I will open to you any questions that you will have. Yes.
Have you received Georgia response on the survey yet?
Oh yes, that's one. Thanks for asking the question, because I'm worried about response rate. So if any of you who know a TMC contact, I would really appreciate if you can advertise this for us. I can send you the link. I don't believe I have received any response from Georgia. I remember Minnesota, Florida, Rhode Island. I don't think. But if you know someone from Georgia,
Yeah, I will. Thank you.
Okay, that would be great. Thank you. And so anyone, you can email me if you know TMC contacts. Email me. I will email you this survey link. And then if you can help us advertise this survey, that will be great.
Any other questions? Thank
Thank you.
Thank you.
Our final presenter is Mr. Seckin from the University of Florida.
Test. Yeah, you cannot be too nice to it. Good morning, everybody. I realize I'm the last presentation that stands between you and lunch, so I'm going to be as brief as possible and be on time. My name is Ozkul. I'm with the University of Florida Transportation Institute. I'll be doing the presentation, but I would like to acknowledge my co-author, Dr. Scott Washburn at the University of Florida Transportation Institute as well. My today's presentation is about the analysis of heavy vehicle effects on Florida freeways and multi-lane highways, and we use the advanced vehicle performance modeling approach and incorporated this into traffic simulation. I'll start with a brief background of the project. I'll give you the problem statement and then the research objectives that we had. I will also mention, of course, the methodology that we used to complete this project, as well as the PC results, and then I'll conclude with a couple of remarks. Highway capacity manual is considered the primary guide, basically, for conducting the highway capacity level of service analysis in the United States of America and some other countries, actually. An important measure for the traffic stream is the hourly demand volume, which can be measured in vehicles per hour or vehicles per hour per lane. However, capacity in the highway capacity manual is defined in passenger cars per hour per lane. So the passenger car equivalency factors serving as a conversion factor from vehicles per hour per lane to passenger cars per hour per lane. And the current highway capacity manual 2010 values actually was based on a study in the mid to late 1990s done by Webster and Dr. Lilly. In this study, Dr. Lilly and Webster used Corsim 5.0, which is then the most current Corsim. However, most of the commercially available micro-simulation tools, including Corsim 5.0 or the current version, which is 6.3, Vissim, Ames, and Paramix, they are all using a maximum acceleration versus speed table. It's a simplistic lookup table. Basically, for a specific velocity, there is one maximum acceleration value, and it's just a lookup table. So for that specific velocity, your maximum acceleration is determined by that lookup table. In addition, in Corsim, the maximum acceleration is associated with a grade adjustment factor. For specific grades, this value will be multiplied by this grade adjustment factor. However, there's really no one calculation behind this. It's also a lookup table, and so the relationship is a little convoluted. Therefore, basically, the effect of the grade on maximum acceleration is really not properly accounted for. In addition, in none of these commercially available micro-simulation tools, the transmission gear changing is really accounted for. There is no one way of seeing what gear the current vehicle is at. To combine all of these assumptions and the shortcomings of the traffic simulation tool, we are basically overestimating the vehicle deceleration, because if you're able to have your truck go from 10th gear to 9th or to 8th to 7th, you're basically going to have a lesser deceleration than what these traffic simulation tools are actually accounting for. Therefore, we are underestimating the traffic speeds, and which makes us basically have our trucks have more impact on the traffic stream, so we are overestimating the PCU values. And then overall, you're underestimating your capacity on the roadway. So all of these bullet points that I'm underlining here is really important for operations. So our research objective for this project was basically to develop an advanced or a full vehicle dynamics model and incorporate that into traffic simulation so that we can actually account for the gear changes of these trucks and see the effects that we're going to be getting. In addition, after that, we want to determine an accurate passenger car equivalency value estimation formulations so that we can develop new PC values and compare them, if you will, to the HCM values, even though we will see later on in my slides that a direct comparison is, we found is really tough. However, I'll hit that later on. So the methodology We were blessed to be able to approach the Florida Department of Transportation, and they had 24 active permanent way motion station data all the way from 2008 to 2011, and they just gave us all this data. However, the data was raw, and I'll talk about the raw data in just a little bit. They also gave us a DVD that contains traffic information from freeways and highways in Florida that has AADT and then total commercial truck volumes per class. And what I mean by class is this is the FHWA vehicle classification chart. I'll hit the really important ones for this study is classes 5 and 6 is our single unit truck. It has 2 axles and 3 axles. I have my class 8 here. This is the day cab where if you would like to think of this as the Coca-Cola Pepsi trucks, they are doing their little in routes and they don't have the sleeper cab. And then we have our class 9. This is the typical freight truck that you'll see on the interstate. It has 5 axles. It has about a 53-foot trailer. And then we have classes 11 and 12. You might see these as a FedEx or UPS trucks. They have the double trailer on the interstate. By looking at the overall truck classification history as a percent of the truck AADT, we were able to observe the ones that I just said, 5, 6, 8, 9, and then 11 and 12 have the higher percentages on the Florida freeways and multi-lane highways. Therefore, we basically said that the truck fleet mainly, I think it was about more than 88% of the commercial truck fleet consists of these 6 classes, if you will. So we split them into single unit trucks, intermediate semi-trailer, which is the class 8 day cabber, interstate semi-trailer, which is your class 9. This basically substitutes about 53% of the overall truck fleet on the freeways and multi-lane highways. And then we have the semi-tractor plus the double trailer combinations. So going back to, I think, the DVD analysis was the really easy one. However, the way motion data analysis wasn't as straightforward. It was raw data, and apparently for all the different detector loops that you have a specific vendor tool that you have to run their analysis basically to be able to convert the raw data into ASCII format. Once you have the ASCII format, you can actually open the raw data, because before you run it through this tool, which was HAT, and I can give you more information if you email me at the end. We ran this and then we can get the ASCII format, but we had about over 40,000 data files, and then in them there was lines and lines, tens of thousands of lines. So we figured out that it'll take us about a year just to go through this data. So we had to develop a C# code so that the C# code can do this for us real quickly. So we developed this, I call it data harvester. Dr. Washburn hates that terminology, but we developed this data harvester code that basically can give you the option to select your stations, and 99 stands for Way in Motion Station in Florida, and then the last 2 digits basically tells you which station number that is. And you can choose any or a combination of the stations that you want. You can also select the years that you would like to do the analysis for. Then we also wanted to look at the time of day analysis, morning, midday, evening, or you can do a full day analysis. So once we run this data, you can see that number of vehicles per class. So I can get the classes, and we did this through basically the axles of the vehicles, because the way motion data has the number of axles of a certain vehicle, and then you can get the total number of vehicles, and then the average weight, average length, and the average speed. So we actually basically have actual field data for these specific vehicles. So once that was completed, we had the data to be able to incorporate into the simulation tool. So we had to make a simulation tool choice. At University of Florida Transportation Institute, CORSIM is typically the simulation tool of choice. And the reason for that is, of course, MacTrans. The code is maintained at University of Florida, and we have regular access to the source code as long as we're working on the projects. However, as I mentioned before, CORSIM 6.3 has some challenges for the purposes of this project. The method of determining maximum acceleration truck is basically just a lookup table. And also the convoluted relationship between these maximum acceleration values and the grade adjustment factors. And the biggest disadvantage we had to be able to use CORSIM was the software architecture. CORSIM uses Fortran, which is a really old code, and it's spaghetti code. So to be able to incorporate a full vehicle dynamics model into CoreSim was really challenging, and also there is no one guarantee that once we make this incorporation into the CoreSim actual code, it's going to recompile, since the code is really old. So what we decided that we're going to use a custom microsimulation, traffic microsimulation tool. We basically use C#.NET framework. It's an object-oriented architecture. We can add or take out basically whatever components that we want to, and it's just not going to be specifically for this project. It can be built upon for different projects in the future. We use most of the vehicle logic is similar to the CoreSim 6.3. I went through the code of 6.3, the CoreSim 6.3, and also looked at the flowcharts so that we can stay as consistent as possible, because we know CoreSim is very strong in these areas. We made a couple of changes. We used the modified pit car following model because we felt that that's working much better than the pit car following model. Also, the discretionary lane changing. We bias the slowest vehicles to the outermost lane. This is what we felt that is happening on the field, and we basically incorporated change into our custom microsimulation tool. We had to also define a lot of vehicle characteristics. I dived into some vehicle excuse me, vehicle dynamics books, and also looked at some Allison Eaton Fuller web pages to get some transmission gear ratios. I also looked at a lot of horsepower torque curves so that we can actually calculate all these calculations, so that we can account for these actual gear changes in the simulation. This is the animation window from our custom traffic simulation program. It does pretty much what other simulation programs do. You can get the position, X, Y, you can get the link position, desired velocity, so on and so forth. You can get the acceleration. You can see that we're talking about this guy here, number 44. It's a class 9, because I know red means class 9. I know you don't, I'm sorry. And then, so basically, I can see that on this link there is a negative grade because he's decelerating and he's a leader. Gear selected is the portion, if you would like. I'm sorry, this guy is having a lot of difficulties here. The gear selected is the new portion. You do not observe this in any other traffic microsimulator. Gear selected, I can see that this guy currently is at gear 9, and he has 10 gears is built into the system. And his overall gear ratio, you can also observe the engine speed, torque, and the power. And all of these values basically are calculated per time step. So you can observe it for each specific gear, because those values will not be the same. If I drop that gear from 9 to 8, those values are going to rev up. So after we incorporated everything into the traffic simulator, we had to validate our results. We used TruckSim for these purposes. TruckSim provides basically a detailed analysis of individual trucks. So it's not a micro simulation tool, if you will. It's just on a per truck basis. It's based on mathematical models of the commercial truck's powertrain, which is basically the engine and the transmission, and also the truck's physical characteristics. What I mean by that is, I know Subway has create your own sandwich. TruckSim has create your own truck. So you can basically choose the tires, what kind of tires you want to have on your truck, what kind of transmission, what kind of engine, what kind of suspension. You can name it, and you can basically just specify in TruckSim. In addition, you can also specify your payloads. You can change the center of mass, of course, change the weight of the payload. And also you can choose your roadway. So you can have dry conditions, wet conditions, you can have snowy conditions, you can have pavement, you can have gravel. You can basically just change all of these, and then you can make a real analysis of what the real world will basically represent. Once we have that, we ran basically, we did an extensive literature review. However, I really cannot put everything in here in this 15-minute timeline. So what we did was we looked at the current literature for the maximum vehicle acceleration models, and then we tested some, the most three prevalent ones against TruckSim. And then what we observed was, excuse me, what we observed was TruckSim is able to do its gear changes in its analysis. However, the other approaches are unable to observe these gear changes, so they are basically just a linear model the acceleration goes linearly upwards from, say, negative 1.5 in that example to negative 1.4, 1.3, so on and so forth, until either the grade drops or your truck is able to accelerate after reaching the end of that graded section. So therefore, we observe the need to develop the full vehicle dynamics modeling approach. The approach at the most basic level is basically a force equation. Force is equals to mass time acceleration, and then the aerodynamic resistance, the rolling resistance, and the grade resistance. Tractive effort, which is basically where your truck is going to be able to drive its acceleration criteria, is the lesser of the maximum tractive effort, which is basically the force that's generated between the pavement and the tire interface, or your engine-generated tractive effort, which is the function of the engine torque, transmission, and all the other forces, differential gearing and drive wheel radius. So for vehicles with lower power to weight ratios, which is basically the commercial trucks, engine-generated tractive effort is normally nearly always the controlling factor. After we incorporated all of this new methodology into the custom traffic tool, we ran many scenarios. This is just one of the scenarios that I'm just showing you here. So it's for a 2640 foot, 6% grade link, and I have my class 9 interstate semi-trailer, which is what we see about 53% on the freeways or highways. And you can see that the blue is our custom simulation tool, and then red is the truck sim results. You can see that there is a gear change. Say this was the gear 9, when my vehicle is coming into this grade, and then it's able to drop the gear 8, and you're able to see this. In the earlier analysis that we did from the literature, you were not able to see, Trucksim was doing this change, but you were not able to see this change in the actual model itself that is being in the literature. So you will see some kind of a model that will basically just have a linear relationship, so there won't be this sudden shift in the acceleration, if you will. We were really confident because all of our velocities were nearly on top of each other, so we were really confident that we are replicating what's going on. After we were done basically validating and building this experimental design into the simulation code, we looked at multiple different scenarios for passenger car equivalency values. The number of lanes, roadway grade, free flow speed, segment length, and heavy vehicle percentage in the roadway. So I'll wrap this up real quick. Classes 8 and 9, even though they initially looked to be probably a little bit different, were very similar to each other. So we combined these basically under a 3 category, if you will: small, medium, and large trucks. And then we use regression to be able to come up with these PC estimation equations. And we have 6 different variables that you can account for. So for each significant scenario that you have, you will have one PCE value. So there's no, similar to HCM right now, there's no one typical scenario, typical truck, or a typical segment length, so on and so forth. You can basically, for your specific scenario, you can just put in the numbers here and you will get your PCE value, and that will be exactly for the scenario that you're looking for. So the new advanced vehicle dynamics modeling approach, to conclude, ensures that the deceleration on grades is not overestimated, and it does this through the accounting for the gear changes for the heavy vehicles. Even though it's difficult to compare, as I said, because HCM does a lot of typical truck and the typical segment length values, so on and so forth in its tabulation, our study basically does very specific values, so it's really tough to compare one-to-one. However, we run some analysis with those typical values and we think what might be typical, and our values, as expected, they are lower in general as in PCEs. So we believe that in the HCM there might be some overestimation. With that, I conclude my presentation. Thank you so much for your attention, and I open your questions.
Couple of questions. 1, 2 questions.
Too nerdy. Thank you.
Thank you all for attending. Like to give all the speakers another round of applause.